If a toy train speeds up over a distance of 25 centimeters in a time of 4 seconds, winds up at a speed of 8 centimeters per second, how fast was the toy train moving when it started speeding up? One of the hardest things about kinematics questions is that they don't usually tell you which kinematics formula you're going to wind up using. Now, this one, it might make sense given the order in which I've kind of been progressing here. This one is going to correspond to the third kinematic formula. But how do you know that? How do you figure that out, right? So I often, what I do is I've read it once, and I've kind of got a visual, at least in my head. I've often encouraged drawing a picture, but I think for this one, I've kind of got a visual that's good enough. But what I'd like to do is kind of go through an exercise of trying to take these numbers and put them into variables that might make sense and will help me to figure out like what my strategy is going to be. So I'm going to start with that 25 centimeters. I think probably a good way to look at this is to say that delta x, I mean, I kind of said like there are, like you can use delta x's instead of x and x naught in kinematics formulas. That's the most common one that I really find makes problems easier to do that. And this is a good example of that because I'm just given a distance here. This, I don't know, I'm imagining this train moving in a straight line. So distance versus displacement is not a big deal here, but I'm just going to say delta x because that normally we think of as being displacement. But I'm just going to assign that 25 centimeters value because we're saying it's speeding up. It's like what I'm imagining in my head is this train is in a process, and as it is doing this process, it is traversing a distance of 25 centimeters. That's the way I'm interpreting this language. The amount of time that it is taking for that to happen is 4 seconds. So that's how I'm interpreting that second number. And then it says winds up at a speed of 8 centimeters per second. So we're definitely given a speed there. But how do I know if that's an initial speed, right? Like if I wrote down that that's a v naught, I might be tempted to go and look at either the first or maybe the second kinematic formula. Probably wouldn't be the second though, because there's a delta x, and the second one doesn't have anything to do with that. But the first does have a v naught, but doesn't have a v. And it turns out this one I think is a v because it says winds up. So v means final velocity. So this 8 centimeters per second is a final velocity. And so those are the things that are given to me, right? But then it says, how fast was the toy train moving when it started speeding up? So that's where, okay, maybe I would have caught that if I'd accidentally thought this was the initial velocity. I would have recognized, how can I be asking the initial velocity if it was given to me, right? But that really is the question here. And if I think about the kinematic formulas, right, like the first kinematic formula has acceleration, and I have nothing about acceleration here. It's not even mentioned. So does the second kinematic formula, and it also doesn't mention displacement. So, okay, but the third one is a good match, especially if you write it in this form. When you look at, oops, let me make that one a v naught. Make that naught a little bit better there. If you look at the variables that I'm working with, there's like a perfect correspondence between them. And the one that I'm being asked about is that one right there. So if I could somehow just isolate that one algebraically, I think I'd be able to solve this question. So let's go ahead and do that. And I've said before, I like to work in symbols. It's perfectly fine. If you wanted to go with this and say, you know what, everything's in centimeters a seconds. Let me just put in like 25 is equal to v naught plus 8 over 2 all multiplied by 4, and then solve for v naught. You can do that. It's maybe frowned on a little bit in many physics classes to do that. I want to encourage everyone to get into some different habits, mainly because that type of methodology will start to serve us less and less as we go on. So what I'm going to do instead is let me start to do the algebraic manipulations more formally. So maybe what I could do is I could multiply both sides by 2, and I'm going to go to divide by time on both sides as well, and recognize that if I do that, I then have this expression. And remember, v naught is a thing I'm trying to isolate. I've got this arrow to help me remember that right there. I've got it up there to help me remember that, because that's one of the things about formal equations is we're not used to this, because in math classes typically the thing we're isolating is the only thing that's not a number, whereas when you're doing this more formal type of methodology, that's not true. So you have to have some way of mentally being clear, which thing am I trying to isolate? I think if I subtract v on both sides, I will wind up getting that v naught is equal to 2 delta x over t minus v. And so then in that last step, I can go ahead and look at all the numbers that I have and say 2 times 25 centimeters divided by 4 seconds, and then subtract from that the 8 centimeters per second, and I'm including all the units. That's one reason, by the way, that if you ask, like, why did I not like that other method? I mean, sometimes I do it as long as units are consistent, but the one thing I lose is the ability to catch my mistakes by tracking units. So doing it this way is good, but it's a lot of work to do that in each step. So it's nice to have it in one last step. So that's kind of why physicists do this. There's a certain style, again, a little different than typical in math classes, but at this point, calculator time, I think I can just put all these numbers, I can see each one's a centimeter per second, and my calculator spits out for this a value of 4.5, and I'm going to interpret that as a 4.5 centimeters per second. Maybe it should be a 4.50 to give myself 3 significant figures of confidence on the certainty here. There it is. And again, if you didn't do that, I wouldn't mark you off in this class. I'm actually not that picky.